Probability distributions. So we'll have discrete and continuous probability distribution. For today's class, we will discuss the binomial and Poisson, which is the binomial probability distribution. We have four properties, which is there are n identical trials, and each trial has two possible outcomes, which is successful and failure. The probability of the two outcomes remain constant for each trial. The probability of a successful denoted as P, which does not change from trial to trial. While the trials are independent, which is the observations from the outcome of one observation does not affect the outcome of the other one. So our interest in the number of successful occurring in the n trials, and we will let x denote the number of successful occurring in the n trials. So let's say the possible distribution, binomial distribution setting will be either defective or acceptable, which is success and fail. And then let's say a marketing research firm received the survey response that yes, I will, or no, I will not. A new job application either accept or reject, which is generally called successful or failure. And the rule of the combinations is NCX, and then with the nx, which is the n factorial and the x factorial, equal to n factorial divided x factorial, n minus the event x factorial. Okay, factorial meaning that, for example, if I say 3 factorial, meaning that 3 times 2 times 1. Okay. And the symbol, this one we call it as factorial. So in somehow this one actually we can write NCX equal to n factorial divided x factorial n minus x factorial. Even if you do know this one also is fine, because we can use calculator for this one. Okay. Let's say binomial distribution formula. We are using the combination formula, which is this one, NCX. Then now multiply with the probability of the successful, which is P power x, and then x is the number of trial, and then now this is 1 minus x is the failure. So we will have NCX P power x multiply Q power n minus x. Okay. For example, a firm A bought 10 computers, and if the probability of purchasing a defective computer is 0.08, what is the probability of purchase 2 defective computers? So from the questions, we know that x equal to 2 because we purchased 2 computers. And the n equal to 10 because, sorry, we know x equal to 2 because the event now we can say let x equal to the defective computer. So s will equal to 2 because now there's a 2 defective, n equal to 10 because we purchased, the firm A purchased 10 computer, and the defective probability is 0.08. So therefore substitute inside, n is 10, x is 2, p is 0.08, and then 1 minus p, this is 1 minus p, which is 1 minus 0.08, power 10 minus 2 will have 0.1478, and I will accept 2 to 4 decimal places. So meaning that you can either give in 2 places, 3 decimal point, or 3 decimal also is fine. And next we move on to the next example. What is the probability of one success in 5 observations, and the probability of success is 0.1. So from the question, 1 success in total 5 observation, probability equal to 0.1. Okay. So substitute inside, we can get 0.32805. Okay, if you do want to use this, we can use this one, PRQ 1 minus R. Okay, R or which is equivalent with X. I just change the symbol. So here will be 5 C1, probability is 0.1, 1, and then we get 1 minus 0.1, which is 0.9, and then 5 minus 1. So which is 5C1, 0.1 power 1, 0.9 power 4. Okay, so we will get the same answer. Next example, suppose the probability of purchasing a defective computer is 0.02. What is the probability of purchase 2 defective computers is a log of 10. So meaning that x equal to 2, n equal to 10, probability equal to 0.02. So we just substitute n equal to 10, x equal to 2, p equal to 0.02, we will obtain 0.1531. So or else we can use the formula NCX. This is the formula NCX p power x 1 minus p power n minus x. So n times x to p is 0.02. Substitute inside, we can get 0.01531, which is same with this one. And we can compute the mean variance and standard deviation for the binomial distribution, where mean is equal to NP. Mean equal to expected value equal to NP. Variance is sigma square equal to NP multiply 1 minus Q, 1 minus P, or some book might say that might use a different formula, which is variance square equal to NP Q. Okay, same. Where Q actually is 1 minus P. Up to you. You can either use this one or this one, so fine. Standard deviation is the square root of the variance. Events is concerned about a low retention rate for employees. In recent years, management has seen a turnover of 10% of the hourly employees annually. Thus, for any hourly employee chosen at random, management estimate a probability of 0.1 that the person will not be with the company next year. So now we have the keyword turnover 10% and then probability 0.1. Now the question asks, choosing 3 hourly employees at random, which is x equal to 3, what is the probability that one of them will leave the company this year? So which is, they say choosing 3 employees, which is n equal to 3 and then 1 leaving, so x equal to 1. Then next, compute the mean and standard deviation. So p equal to 0.1, n equal to 3, and x equal to 1. Substitute inside, we can get 0.243. To compute the mean, we can use the formula Ex equal to NP, which is 3 multiplied 0.1, which is equal to 3. variance, which is n multiplied p multiplied 1 minus p, which is 3 multiplied 0.1 multiplied 0.9, which is equal to 0.27. Standard deviation is the square root of the variance, which is square root of the 0.27. We will get 0.52. And next, we'll move on to the Poisson distribution, where Poisson distributed random variable is often useful in estimating the number of occurrences over a specific interval of time, distance, or space. It is a discrete random variable that may assume an infinite sequence of values. The probabilities of a Poisson experiment is the experiment consists of counting the numbers of times an event X occurs in a given interval. The interval can be an interval of time, area, or volume. But the probability of an occurrence is the same for any two intervals of equal length. Let's say if X is equal to the number of occurrences in a specific interval, then X is a Poisson random variable. For example, the number of computer crashes in a day, or the number of car accidents per month. So here we can know that, let's set the number of accidents per month. We have to use the counting the number in event, counting times in an event, which is 1 month, how many? And then for the first example, in a day, how many? And the keyword for the Poisson distribution is average. So let's see the formula. Poisson formula Px equal to exponential power negative lambda multiply lambda power x divide x factorial, where x is the number of successful per unit, and then lambda is the expected number of successful per unit, which is the average number of occurrence in the specific time span. And exponential actually is, if you just press the calculator, exponential power 1 equal to 2.71828. So now we move on to the example. Suppose that an average 5 cars enter a parking lot per minute. Since we have a time frame per minute, what is the probability that in a given 7 minutes, 7 cars will enter? So meaning that now x equal to 7, lambda equal to 5, because the keyword here average. Average how many? 5 cars. So average 5 cars, lambda equal to 5. And we just substitute lambda equal to 5, and x now is equal to 7, which is exponential is a fixed point. Exponential, you can use a calculator, then you can get exponential power 1 is 2.7 something. So we can, if for those who want to use the value, you can just press shift to the log, you can get exponential. So exponential power, now we know that lambda is 5, and then substitute inside, and x equal to 7. So we'll obtain 0.104. So in conclusion, there's a 10.4% chance 7 cars will enter the parking in a given minute. Okay, so this is, I just copy back from the questions, because the question says 7 cars enter the parking per minute, okay, or in a given minute. Next, a patient arrived at the emergency room of Kamda Hospital at an average rate of 6 per hour on weekend evenings. What is the probability of 3 arrivals in 30 minutes on a weekend evening? So now lambda equal to 6 in 1 hour. Why? Because here they said average rate 6 per hour. But then now they ask only 30 minutes, meaning that we have to divide 2. So since 6 in 1 hour, so 30 minutes is equal to 3. And since the question asks them just want 30 minutes, so we just use this lambda. lambda equal to 3. And then they ask what is the probability? 3 arrival. So x equal to 3. Substitute x equal to 3, lambda equal to 3. Then we can get 0.224. And next, a phone call arrived at a sweet spot on an average rate of 2 calls per minute. If the number of calls in any time interval follows the Poisson distribution, then let's say x equal to the number of phone calls in a given minute. Now we know that the question said average 2 calls per minute. So in a given minute, then we will have 2. And next, in a given hour, 1 hour we have 60 minutes. So 60 multiplied 2, we have 120. 15 seconds, we know 1 hour we have 60 seconds. So 15 seconds meaning that 15 divide, since 1 hour 2 calls. So now 1 minute we have 60 seconds. So 15 seconds will be 15 divided 60. Okay, 15 divided 60, we will have 1 over 4, then we will get 0.5. And next, find the probability of exactly 5 calls in the next 3 minutes. Now, 5 calls, so we know that the event or x equal to 5, but then now they do 1 minute. 1 minute, we know that there is 2 calls. 3 minutes equal to 2 multiplied 3. Okay, so let's say we don't want to use x, up to you. You can use x or you want to change another alphabet or symbol also can. Let's say y equal to the number of calls in the next 3 minutes. So lambda will equal to 2 multiplied 3 equal to 6. Why 2 multiplied 3? Because it's 2 calls per minute. And then since we have 3 minutes, so 2 multiplied 3, we have 6 calls per 3 minutes. Then we substitute inside the formula, lambda power x multiply exponential power negative x divide x factorial. Then we will obtain 0.1606. Okay. Or you can give me the value after multiplication, or you can just substitute inside is enough. Let's say for this one, we know that lambda equal to 6, and then power 5 exponential power negative 6 divide 5 factorial. And next, find the probability of at least 2 phone calls in the next 3 minutes. At least 2 phone calls. So, since we know that 3 minutes we will have 6 in average. So now at least 2 phone calls, meaning that we just want to ask more than 2 or greater than 2. So this is how we want. 6 phone calls, we just want 2, 3, 4, 5, 6. And 1, 2 is we don't want. So we can either by calculate 1 by 1, probability when x, when y equal to 2 plus when y equal to 3, when y equal to 4, when y equal to 5, when y equal to 6. Or we can just use 1 because we know that the summation of the probability is equal to 1. So we can use 1 minus the complement, which is the don't want one, which is 1 minus when the probability is equal to 0, when the probability is equal to, when the x equal to 0, or when the x is equal to 1. Therefore, substitute when x equal to 0, we will obtain 0.2479. When x equal to 1, we will have 0.14874. When x greater than and equal to 2, then we can just use 1 minus when the event is equal to 0, or when the probability of the phone call is equal to 1, then we will have 0.982647. Okay, so this is method A. If you don't want to use 1 minus, you can use the method B, which is the method B will be you calculate when x equal to 2 plus when x equal to 3 plus when x equal to 4 plus when x equal to 5 plus when x equal to 6. You will get the same answer. So this is the summary for the Poisson distribution, where we can calculate the mean, which is mean equal to lambda, because this lambda is the average, right? Average and mean is same. While to calculate the variance sigma squared is equal to lambda. Standard deviation is equal to square root lambda. And that's all for chapter